Hey class, in today's lesson we're going to talk about graphs of rational functions, which is found in section 2.7. Our objectives are to analyze and sketch graphs of rational functions and to decide whether graphs of rational functions have slant asymptotes. So there are so many parts to truly graphing a rational function by hand. And here they are. So it says let f of x equals n of x over d of x, where n of x and d of x are polynomials with no common factors. So step one is to find and plot the y-intercept, if any, by evaluating f of 0. So in other words, substitute 0 into your entire function. Whatever is left over, you'll write your intercept as, and remember, y-intercept should be written as 0, comma, the number. Number 2 says find and plot the x-intercepts by setting the numerator equal to 0. And we know that to find x-intercepts, we're setting it equal to 0 by factoring. And then to write x-intercepts, remember, that's the number, comma, 0. Step 3 says find and sketch the vertical asymptote by setting the denominator equal to 0 and using dashed lines. So remember, vertical asymptote was the same thing as like finding the domain, where we just set the denominator equal 0. And we will just get x values. So these will look like vertical asymptote as x equals whatever the number or numbers are. That will create dashed lines. Step 4 says check the powers of the leading terms to determine the horizontal asymptote and sketch using dashed lines. And again, we just did that in our last lesson. So horizontal asymptotes are y equals, they are horizontal lines. Step 5 says plot at least one point to the left and right of each x-intercept and the vertical asymptote. So this is where, in other words, we're testing the values that surround these major points. So that we can actually get a shape for our graph. And then finally, you just use smooth curves to graph the function. So let's take a look at this in action. So for example 1, it says to sketch the graph, g of x equals 3 over x minus 2. It says to sketch, but really it's just it's a sketch because it's not truly complete, right? We can't really complete the graph fully. It would take forever, but we're just getting the key pieces on here. So the first step was to find the y-intercept. And so to find the y-intercept, remember, you evaluate your function by making all your x's 0. So g of 0 would be 3 over 0 minus 2. That would be negative 3 halves. So as a y-intercept, that ordered pair would be 0, comma, negative 3 halves, or negative 1.5, same thing. The x-intercept then is just setting your numerator equal to 0. So if I try and set 0 equal to 3, well, that's not an option. So in that case, there is no x-intercept. All right, next for the vertical asymptote, remember that means setting your denominator equal to 0. So x minus 2 equal to 0. If I add 2 to both sides, I will get x equal to 2. So that is my vertical asymptote. My horizontal asymptote would be me focusing on the powers. So the power of my numerator is 0. The power of my denominator is 1. So since 0 is less than 1, then my horizontal asymptote is y equals 0. Finally, we need to check values that surround 0 and 2. So the values that surround 0 are negative 1 and positive 1. And the values that surround 2 are just 3, right? So I can just check the next one. So if I created a table of values and I started with negative 1, I would have negative 1, 0, 1, 2, and 3. Negative 1, and what we're doing is we're just putting these values back into our original function. So that'd be 3 over, for example, negative 1 minus 2. Negative 1 minus 2 is negative 3, and 3 divided by negative 3 is negative 1. I was just showing you how to find these values, but the rest I won't show. So 0, we actually already know, is negative 3 halves because we found that as our intercept. 1 we don't know, so again you would sub in 1. That'd be 3 over negative 1, which would give us negative 3. If I sub in 2, I don't actually need to because we found it here as a vertical asymptote. So 2 does not exist. It's undefined. It is undefined at that spot. And then 3, if I subbed in 3, 3 over 3 minus 2. 3 minus 2 is 1, so 3 over 1 is 3. All right, then we're going to create a graph that has these important numbers on them. All right, first I'm going to plot my y-intercept as 0, negative 3/2, which is 0, comma, negative 1.5. So it's negative 1.5. The x-intercept, there is no x-intercept. The vertical asymptote is at 2. So that's just a vertical line at 2. The horizontal asymptote is 0, so that is the x-axis. And so whatever our graph shape has to be, it has to be along the lines of or bounded by this cross action. So anyways, if we were to graph, I'm going to plot the rest of these ordered pairs from my table. All right, so negative 1 is here. 0, negative 3/2 was our y-intercepts. I already have that. 1, negative 3 is here. 2 is undefined, and 3 is here. I actually did this to include one more ordered pair just because I can't really see what's going on over here. So if I include 4, that value is actually going to be 3/2. So 3/2 is really 1.5. So at 4, it's 1.5. And so now I can see that my shape is going to do something like that. And again, you can take a look at your graphing calculator and you would see a similar graph. All right, let's look at our next problem. We need to sketch the following information. So again, let's start over with our y-intercept. So to find the y-intercept, remember that means to make all of your x's 0. So that'd be 0 over 0 squared minus 0 minus 2. That's really 0 over negative 2, which makes this 0. So our y-intercept is 0, 0. Next, we find our x-intercept. That means to set your numerator equal to 0. So that would simply just be x equals 0. But, sorry, made a mistake. Since x equals 0, then as an ordered pair, your intercept is 0, 0. So your x-intercept and your y-intercept are the same. That makes sense because that's the only place that both of them can be the same number. Our vertical asymptote, to find that means to set your denominator equal to 0. So x squared minus x minus 2 equals 0. I would just factor using AC. The two factors that would work are x minus 2 and x plus 1. And so those vertical asymptotes would be x equals positive 2 and negative 1. So we would create vertical lines at those two areas. And then the horizontal asymptote is checking your power. So I have a 1 in the numerator or 2 in the denominator. So 1 is less than 2. And so since it is less than, your horizontal asymptote is y equals 0. All right, so we have some pretty important numbers here. I think my furthest left number is negative 1. So if I create a table, I want to go from negative 2. And then let's keep going down. So negative 2, negative 1, 0, 1, 2, and I'm going to go one step further and go to 3. Okay? And let's look at these numbers. Negative 2, if I subbed in negative 2 into our function, we would get negative 1/2. If I subbed in negative 1, well, really I don't have to because I already found it as a vertical asymptote, so that means it's undefined. 0 is 0. I know that as being both my y-intercept and my x-intercept. 1, if I subbed in 1, I would also get negative 1/2. If I subbed in 2, there's no point because, again, it's a vertical asymptote, so that means it's undefined. And finally, if I subbed in 3, I would have 3/4. So this one's going to be a fairly tiny graph. We have some decimals. So to put my points on here, my y-intercept and my x-intercept are both 0, 0. And then I see some asymptotes. I have a vertical asymptote at +2 and at -1. And then we have a horizontal asymptote on the axis. So with that being said, we're going to plot our additional points that we found from our table. So that's -2, -1/2, which is here. I have a -1, which is undefined. 0, 0, I have that. 1 is -1/2, so that's about here. 2 is undefined, and 3 is 3/4, so almost 1. I'm going to tell you now, technically I should test another point. Technically I should test -3, and I should also test +4. But because I know the shape of the graph is actually just going to do something like this. And you guys may be asking, well, Miss Richardson, if y equals 0 is a horizontal asymptote, why does the center one cross? It does only in situations like this where it's so close together, but as you move further out on the graph, it will not continue to cross. It's more like a calculus theory type of answer, so I won't go too into detail. Just know that for this problem, it's okay. It does work. All right, if we sketch this function, all right, let's find all of our important pieces of information. The y-intercept, remember, just means we set all our x's equal to 0, so that'd be 2 times 0 minus 1 over 0. You cannot divide by 0, so there is no y-intercept. Okay, to find the x-intercept, that means I set my numerator equal to 0, so 2x minus 1 equal to 0. If I add 1 and divide by 2, I get x equal to 1/2. So as an intercept, that would be 1/2, 0. Our vertical asymptote is setting the denominator equal to 0, so that's just x equals 0. And our horizontal asymptote is checking the power, so they're the same power. So our horizontal asymptote is y equals 2, because we look at the coefficients. So from there, if we create a table, I have my main value is really only 1/2. So I should create values that's around 1/2. So I'm going to choose -1, 0, and 1. And we'll see what we get from those values. So if I sub in -1 into that function, that'd be 2 times -1 minus 1 over -1, which is -2 minus 1 over -1, which is just going to give us -3. Sorry, +3. If I sub in 0 throughout, we already know what happens there. It is undefined, and we knew that because it's the vertical asymptote. If I sub in 1, that'd be 2 minus 1 over 1. So 2 minus 1 is 1, divided by 1 is also 1. So if I try to graph this function, all right, there's no y-intercept. The x-intercept is at 1/2, 0, so that's about here. The vertical asymptote is at x equals 0. So that's the y-axis. And then the horizontal asymptote is at y equals 2. And if we continue to plot just a few more points, we have the ordered pairs, -1, 3, so that's up here. 0 is undefined, and 1, 1. Now, honestly, that's not showing me enough about my graph. I know what's going to happen, but I doubt most of you guys would. So what you should do, after testing 1, you should also test 2, and you should also test -2. The value for -2 is 5/2, which is 2.5, and the value for +2 is 3/2, which is 1.5. So if we plot those, -2 and then 2.5, that'd be a little lower. And if I plot 2 and 1.5, it's also, that's a little higher. So this graph will essentially make this shape here. And that's it. Let's take a look at our next problem. All right, so we're going to sketch the following graph, but in order to do that, we need to find our y-intercept first. So our y-intercept would be making all the x's 0. So it'd be 2 times 0 squared minus 9 over 0 squared minus 4. 0 squared minus 9 is actually negative 9 times 2 is negative 18 over negative 4. That reduces down to 9/2. So our y-intercept is 0, 9/2. Fun. That's really 4.5. Okay, the x-intercept is setting your numerator equals 0. What I want us to realize is x squared minus 9 is a difference of squares. So it's x minus 3 and x plus 3. So if we set those x-intercepts equal to 0, we would have, and we're ignoring the 2 because if I set 2 equal to 0, it does not exist, or it's not a true fact. So we would have as intercepts 3, 0, and negative 3, 0. All right, if we keep going past that point to find our vertical asymptote, remember with the vertical asymptote, we are setting the denominator equal to 0, so x squared minus 4 equal to 0. That's also a difference of squares, so x plus 2 and x minus 2. Sorry, made a mistake. So those x values are plus or minus 2. And then finally, our horizontal asymptote is just checking our powers. So be sure that you understand that I would need to multiply. So that'd be 2x squared minus 18 over x squared minus 4. Checking those powers, they're the same. So we check the coefficients. So that's going to be y equals 2 over 1, which is 2. All right, some good values to have here. So the furthest left value that I have based off of intercepts is negative 3. So we're going to go one more to the left and make that negative 4. And the farthest right value that we have is 3, positive 3. So we're going to go all the way up to positive 4. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. All right, negative 4, if I sub that value in to our function, I'm going to get 7/6. Oops, that's the highlighter. So 7/6. If I sub in negative 3, there's no point because it is 0. I know that because of the x-intercept here. If I sub in negative 2, there's no point because it is undefined. I know that from my vertical asymptote, which means I also know that this 3 down here is also 0, and that 2 is also undefined for the same reasons I just stated. All right, if I subbed in negative 1, that would give me 16/3. There's no point of subbing in 0 because I know it from my y-intercept, which is 9/2. And then finally, if I put in 4, that's 7/6. Now, for graphing purposes, it would be possibly nice for you to find out what these fractions are closely related as far as real numbers are concerned or whole numbers are concerned. But otherwise, we're really just doing good estimates. So here we go. All right, negative 4 and 7/6. Actually, let me put all the good information on here. So the y-intercept is 0, 9/2, and that's 4.5. So if I went a little higher, that'd be about here. Then I have my x-intercepts at 3, 0, and negative 3, 0. My vertical asymptotes are plus and minus 2. So here's my positive 2. Here's my negative 2. And finally, my horizontal asymptote is at y equals 2. Based off of what I see, I can already kind of get an idea of what the shape will be. But let's continue to plot the rest of these ordered pairs. So negative 4 and 7/6. 7/6 is just a little bit above 1. It's 1 and 1/6, so that's about here. We already have negative 3, 0. We already have negative 2 is undefined. Negative 1 and 16/3. 16/3 is like 5 1/3. So that's at negative 1, it's about 5 1/3. So it's just a little bit higher than what I had. We have 0s, 9/2. 1 is undefined. 1 is not undefined. Sorry, I forgot to write that. It's 16/3. So again, parallel to what I just had or symmetric to what I just plotted. 2 is undefined, 3 is 0, we already have it plotted, and 4 is 7, 6, again, that's 1 and 1/6, so that's about here. So this shape of our graph will be similar to this. And again, we can double check on our calculator. Slant asymptotes. So if the degree of the numerator of a rational function is exactly 1 more than the degree of its denominator, then the graph has a slant or oblique asymptote. And we would use long division to determine its actual asymptote. So we've been saying up to this point that anytime when it's greater than, when the numerator's power is greater than the power of the denominator, we've just been saying no horizontal asymptote. And that's true because it's not a horizontal asymptote, it's a slant or oblique asymptote. So now we're going to start trying to figure out what that will look like. So let's look at our next problem. So it says graph the following function. So we have x squared minus x minus 2. So again, go back and find all of our important information. We start with the y-intercept. So our y-intercept would be making all of our x's 0. So it'd be 0 squared minus 0 minus 2 over 0 minus 1. That's negative 2 minus 1, which is positive 2. So as an intercept, that'd be 0, 2. Our x-intercept would be setting our numerator equal to 0. So that would be x squared minus x minus 2 equal to 0. Those factors would be x minus 2 and x plus 1. So those factors or those zeros would be x equals, what is that, positive 2 and negative 1. So as intercepts, though, they would reflect, they would be 2, 0 and negative 1, 0. All right, moving from there, I need to scoot that up. Moving from there, we will take a look at our vertical asymptote. So to find the vertical asymptote, it just means to set the denominator equal to 0. So x minus 1, if I set that equal to 0, x equals 1 is my vertical asymptote. Our horizontal asymptote, if we take a look here, the power is greater than, so there is no horizontal asymptote. It's a h, sorry. But we should check because since it's just 1 power higher, there is a vertical asymptote. And so if we use long division, x minus 1 goes on the outside, x squared minus x minus 2 goes on the inside, and then we divide. Focus on x and x squared, that's x. X times x is x squared, x times negative 1 is negative x. Flip the signs, that gives me negative 2. That also cancels. We don't care about remainders, we just care about what was divided. So our slant asymptote is y equals x. All right, now we should create a table to find values that surround what we've found. The farthest left value is negative 1. The farthest right value we have is 2. So we're going to go from negative 2 to 3. All right, negative 2, if I sub that in, would be negative 4/3. There's no need to sub in negative 1 because it is 0. We know that from the x-intercept. We also know that 2 is 0. We know that 0 is 2 from the y-intercept, and we know that 1 is undefined. So the only other one I need to find is 3. And if I sub in 3 into that function, 3 is 2. So if we graph this, let's put the useful information on here first. So 0, 2 as a y-intercept is here. X-intercept is 2, 0 and negative 1, 0. We have a vertical asymptote at x equals 1, so that's here. We have a slant asymptote at y equals x. So what that means is it's just like graphing a y equals x line. So for example, we know the origin counts in up 1 over 1, up 1 over 1. Go back the other way, down 1, left 1, down 1, left 1. So that will look like this as an entire line. Should have been dashed, but you get the idea. And so from there, the we should plot any other ordered pairs that we found. So the other ordered pair we found was -2 and -4/3. -4/3 is like -1 1/3, so that's down here. So really close to that line. The other one we found is 3, 2. So 3 and 2. So essentially this graph is going to hug the asymptotes. And we are done. Guys, if you have any questions concerning how to graph our rational functions, just be sure to come in and see me for tutoring.